Looking at the nature of stationary points. In our last video, we looked at, for stationary points, remember dy dx equals 0. So for stationary points, remember, for stationary points, dy dx equals 0. So we know that at that point in the curve, the gradient 0. So if you look up here, this is where dy dx is 0. Now, we're going to investigate on the left-hand side of that stationary point and on the right-hand side of that stationary point whether the gradient's positive or negative. Because the gradient won't always be 0 unless it's a flat straight line. Okay? So you tell me what you think's happening here on the left-hand side of this stationary point. Is the gradient positive or negative here? So, what we do, if this is A, if the stationary point occurs at A, look at this table, then when x is A, dy dx is what? 0. But this is A minus delta, means a small value in x or a small change in x. So this is before you get to point A. Okay? So when we do questions, we won't write it like that. This is just the theory. All right? So a little value just before A. Tell me about the gradient. It's positive. And a little value after A. So say here, so this point on the curve here is A minus delta x, and this is A plus delta x. Tell me about the gradient here. Negative. So this is what we've got. If I have, at x is A, I have a stationary point. Look what's happening here. The gradient's positive. I'm just doing it with straight lines. The gradient's 0 and the gradient's negative. What do I do? Positive gradient, 0 gradient, negative gradient. I know I've sort of done it as a, it's not really squarish like that. But when that happens, see, you've got a maximum turning point on the curve. Does that make sense? When your graph goes like that, that's the maximum turning point. The graph turns and that's the maximum. Do you get that? All right, this is a relative minimum turning point. So when x is A, we know that the gradient here is 0. Now on the left-hand side, which is A minus delta x, tell me about the gradient here. Negative. And when this point is A plus a little bit more, A plus delta x, tell me about the gradient there. Positive. So just watching, I've got a negative gradient, I've got a 0 gradient, I've got a positive gradient, I end up with a minimum turning point. Does this make sense? So what we're doing is we're just looking at a curve and we're saying the gradient here is positive, the gradient there is 0, the gradient there is negative, I've got a maximum. Or the other way around, I've got a minimum. Now, there are 3 types of stationary points, even though you can see here we've got 4. We've got a maximum, we've got a minimum turning point, and we've got horizontal points of inflection, but there are 2 types, a backwards one and a forwards one. So the gradient is actually flat at that point. So this is called an inflection. So we've got gradient of the tangent at this point is 0 when x is A. This is A minus delta x, a small value in x. Tell me about the gradient there. What is it? Negative. Tell me about the gradient here at A plus delta x. It's? No. Look at my pen. Negative, 0 gradient, negative. So, watch, negative gradient, 0 gradient, negative gradient. It's an inflection. It's not like it's a kink in the curve, but a horizontal kink. That's an inflection. Look at this. That forms a minimum. Can you see that? That forms a maximum. Positive, 0 gradient, negative gradient, maximum. Can you see this is just a kink in the downward curve? That's called a horizontal inflection. And here we've got another horizontal inflection. Tell me about at A, what's the gradient? What's the gradient here at A minus delta x? And here, so we've got watching, positive gradient, 0 gradient, positive gradient, inflection. It's going upwards, but there's a kink in it, sort of, yes. So this is A plus delta x. So in this exercise, we're just going to investigate the gradient to determine the type of stationary point that it could be. There are 3 types of stationary points. Okay, so in summary, just down here, we've got stationary points. We've got 3 types. we've got a maximum turning point, and that will look like this. Got it? Positive gradient, zero gradient, negative gradient. Get the idea? We've got a minimum turning point. It's all there. Oh, and we've got negative gradient, zero, positive. For stationary points, at the actual stationary point, the first derivative is zero. But what we're doing is we're exploring the gradient or the derivative on either side of the stationary point. Or we can have a horizontal, it must be called a horizontal point of inflection. So we've got zero, positive, zero, negative, negative, zero, positive, or you could have like this or like this. Do you get the idea? Positive gradient, zero gradient, positive gradient, negative gradient, zero gradient, negative gradient. That's what the curves will look like. I know I'm doing them boxy. Do you know what I mean? I'm drawing them squarish. They're not like that. That's really one of these. That's one of those. And this looks like this or this. But I'm drawing them rounded to give a more pronounced idea. So there are three types. So what we're doing today, we'll be doing the first derivative, putting it equal to zero. And then on either side of where the derivative is zero, we're just going to look at the gradient of the curve. Got a couple of questions here. So for this curve, y equals 2x cubed, etc., determine the coordinates of the stationary points and then determine their nature, hence sketch the curve. So dy dx is, let's go, what is it? 6x squared minus 6x minus 12. Then we say, setting out is exactly the same every time. You go for stationary points, dy dx equals 0. So then you put that equal to 0. And what should I do? Beautiful. Divide by 6. What do we do now? No, we're going to factorize. Two numbers that multiply to give negative 2 but add up to give negative 1. It's got to be 2 and 1. Think minus 2 plus 1. So x is 2 and x is 1. So we've got stationary points when x is 2 and when x is negative 1. So now what we're going to do, we're going to draw up a little table. Now I can find the y value as well. Do you want to find the y value? All I know at the moment is the x coordinate of the stationary points. So I'm just going to go, when x is 2, y is, just going to look at it here. Isn't it 2 times 8? So it's 16 minus 3 times 4 minus 12. Minus 12 times 2 is 24 minus 3. I get 4, negative 20, negative 23, I hope. And when x is negative 1, I get that y is 2 times negative 1 will be negative 2. But that'll be 3 times 1, so minus 3. This will be minus 12 times negative 1. That'll be plus 12 minus 3. You get negative 5, negative 8. I think you get plus 4. Now, there are our stationary points. 2, negative 23, negative 1, 4. I'm just going to determine their nature first. So I know that I've got stationary points at those points. Now I want to determine their nature. So let's look at the x is 2 one. So when x is 2, I know that, and I'm investigating the gradient around the point x is 2. I know that when x is 2, dy dx is 0. Now, I've got another stationary point as well when x is negative 1. So what I've got to do here, I've got to choose, so also when x is negative 1, dy dx is 0. I need a value a bit smaller than 2. So you make one up. I'm going to do 1.9. Or look, you could do 1 and 3 if the numbers are going to work better. Look, you've got to be careful. Because 2 and negative 1 are fairly far apart, I could just do the 0.1 and I could do the 0.3. Okay? But let's say I had a stationary point at 2 and another one at 1. I have to go very close to 2 then. Do you understand? All I need is a point on either side of 2. To make it easy to calculate, I'm just choosing whole numbers because the next stationary point is at x is -1, which is, you know, fairly far away. So just a point on either side of 2, but you can't go past another stationary point. Do you get it? So what have I got when x is 1? Dy dx, which is the derivative function. Oh, and the other thing is you have to substitute into the derivative function, not the original function. I'm investigating the gradient when x is 1. What do I get? 6 minus 6 minus 12. -12. Good. And when it's 3, I get 6 times 9 is 54 minus 18 minus 12. 60. Did I say 54 minus 30? 24? There you go. Well, what have you got there, girls? Negative gradient, 0 gradient, positive gradient. What's this? Minimum. So I've got a minimum. It's called a minimum turning point. Are you okay with this? Negative gradient, 0 gradient, positive gradient. Do you see it? Before x is 2, the gradient's negative. When x is 2, the gradient's positive. And after x is 2, the gradient's, when x is 2, the gradient's 0. And after x is 2, the gradient's positive. Negative gradient, 0 gradient, positive gradient. Minimum turning point at 2, -23. Look, generally you can choose 1.9, 2.1. 1.5, 2.5. You know why I chose whole numbers? Because the other stationary point's far away. It's easy for me to do it in my head if I choose whole numbers. So let's look when x is -1. Do a point below -2 and a point above. A great one to choose would be 0. You know, I should get negative for 0 because I'm getting negative for 1. All right, so, and they're between the two stationary points. So let's look. When x is 0, I'm going to do that one first. I get -12. And when x is -2, I get 6 times, that'll be +4. That's 24 plus 12 minus 12, +24. So what have I got? I've got a positive gradient, I've got a 0 gradient, and I've got a negative gradient. Tell me what I've got. So therefore I've got a, can you see that's a maximum? A maximum turning point at the point -1, 4. Now we're going to sketch it. Sorry, you can't see it. How are you going? Do you get it? Let's sketch. I need -1, 4 and 2 -23. So I'm going to have to draw it like this. It's not going to be to scale and it doesn't have to be. So I've got -1, 4. I'll put roughly there. Oh, no. -1, 4 is there. That's a maximum. The curve should look like this. You okay with that? Maximum at -1, 4. So put it and draw a little hump for a max. Then I've got my minimum at 2, -23. So put the point and draw, it's going to look like that. That's the minimum. But look at your original curve, not your gradient function, your original curve. I'm sketching the original curve, not the gradient function. What's my y-intercept? -3. So also I've got that the y-intercept is -3 for this function. So I'm going to make sure it cuts through here at -3. And that's my curve. Now, because there are no other turning points, we listening? You would just continue down here and put an arrow, and that must continue up there. You don't have to know the x-intercepts. That's 3 unit, knowing where the x-intercepts are. So I've got my maximum, I've got my minimum, and I've got my y-intercept. I'll just move that over here somewhere. And I also know that my y-intercept is -3. And that's how you sketch. One, they give me the gradient function. It's already differentiated. You can't work out the original function because you don't know how to integrate. So that'll be our next topic. Yeah. So here is the gradient function. All right. So show that there are 2 stationary points and determine their nature. So remember, when you're determining the nature of the stationary points, you're only really looking at the gradient of the curve before the stationary point, after the stationary point. Does this make sense? So, all right, let's go. So we've got dy dx. So we're going to put it equal to, yeah, sorry, no, I'll write that again. dy dx equals 0 for stationary points. So therefore, we put this equal to 0. X squared bracket 3 minus x equals 0. So you tell me what the values of x that give you 0 are. X is 0 and x is 3. Now, you know why it's saying draw a possible sketch of this curve? Because I know that when x is 0, I can't find the y value because I don't have the y original function. I just know that when x is 0, I've got some stationary point. I don't know how high up or down it's going to be. So let's do our little tables. When x is 0, we know that dy dx is 0, but we need to investigate the gradient on either side. And we know that when x is 3, okay, dy dx is also 0. Yeah. We okay with this? So let's do a value before 0 and after 0. Negative 1, 1 will do. Reason they're easy to work out. And 0, as long as the value you choose after 0 is before 3, it'll be fine. Now, a value before 3 would be 2, and one after 3 would be 4. It's always before and after. Now, you know that 1 is also before 3, so whatever answer we get for 1, in terms of whether it's positive or negative, is going to be the same as the answer we get for 2. All right, let's go. So when x is negative 1, put it in, what do you get? Negative 1 squared is 1. 3 minus negative 1 is positive 4. This is positive 4. So I've got a positive gradient, a 0 gradient. Doesn't have to be negative. It could be positive again. We don't know. When x is 1, I get 1 times 3 minus 1. 1 times 2 is 2. Oh, look. Positive gradient, 0 gradient, positive. That's a horizontal inflection. Let's look at the other one. Has anyone done when x is 2? We get 4 times. We get 4 times 1. And when x is 4, we get 16 times negative 1 is negative 16. Positive gradient, 0 gradient, negative gradient. Do you like this little helps? So therefore, what have we got? A horizontal point of inflection. And we've got a maximum. Because you can see it. Positive, 0, negative. Turning point. A possible sketch. Okay. Now, I know where the stationary points are for the x values. I don't know the y values. So I'm just going to draw a quick curve. When x is 0, I know I've got a point of inflection. I might just draw it a bit up, or I can draw it on the origin. It doesn't matter. And then, so here, when x is 0, I might draw it a bit up. Or do you want it here? I can draw it on the axis. Do you want it on the axis?
Yes.
All right, so I'll go like this. Make sure it looks like that. That's the shape there. And when x is 3, so I'll put x is 3 over here somewhere. When I get there, nothing else happens. But when x is 3, I'll just go up here. I've got a max. So this is a possible curve. Here is my point of inflection. Horizontal POI, point of inflection. Here is my maximum turning point. Max TP. Got it? Inflection, maximum turning point. Because I don't know what the function is, this whole graph could have been lifted up or shifted down. Do you understand? It doesn't necessarily lie in that position. It could have been down here, or it could have been up there, but same shape. Okay? A continuous curve has the following properties. Function of 0 is 2. What does that mean? Does that give you a point on the curve? When x is 0, y is 2. So function of 0 is 2. That means that's the point 0, 2. The function of 1 is negative 1. That means when x is 1, y is negative 1. So that's another point on the curve. So I've got 2 points. I know that f dashed 0 equals, so this is 0. F dash 0, the gradient 0 at 0 equals the gradient at 1, which is 0. The curve is flat there and here. Do you get that? This means the gradient, because first derivative, The gradient at 0 equals the gradient at 1, which equals 0. In other words, we've got stationary points. That's what it's telling us. Stationary points at x is 0 and 1. That's what it's telling us. Do you get that? First derivative is 0 when x is 0 when x is 1. Now, the first derivative is positive, so the gradient is positive when x is negative. So we know that the gradient is positive plus VE for values of x less than 0. Gradient's positive. It has to go like this. Do you get that? Do you get that? Positive gradient.
Oh, and then it goes up again.
And when x is greater than 1, for x is less than 0, x is greater than 1, so the gradient's positive, it has to go up this way. Do you get that? And so we've done that. And the gradient is negative is negative when x lies between 0 and 1. That's a negative gradient. That's what you've got. So what have you got? You got a maximum there and a minimum there. That's really testing your do you get that? All right.